to another episode of Let's Roast Some Gears with DPC and Stubby Fan V4, this time using Nylon 6 as the planetary gear group. It will fail, of that I have no doubt. The question is, when? And that's what we're going to find out today. So I'm going to give everyone a little bit of time to get in here, see what's going on, so on and so forth. Where is everybody? So I'm just getting myself set up here, mentally prepared to lose another set of gears. I'll let everybody kind of roll in if they're interested, and we'll go from there. So I'll give you guys a few minutes just to kind of bask upon the glory of this thing. I can't help myself. It's just too much fun. So I don't know how clear everything is coming through. I will try to move a little bit so that when this is plugged in, you can kind of see the amp meter at least. That'll be good right there, I think. Now, I don't expect as many people to show up as I did last time. This is more or less just to kind of talk about things and then see the fan run again. The gears that I did print, like I said, are Nylon 6. It was the last set of Nylon 6 gears I could print. And this stuff was so hard to basically clean up. I mean, I didn't have to do much cleaning, but like the little strings on it, I'd have to cut with a razor because you couldn't pull them off like with PLA or anything else. There's just an extra gear. I do have, I think, one PETG in there, just because this one cracked when it was annealing. So, hey, Hezekiah, welcome. I am basically going to be spinning up this turbine, but I'm kind of waiting for people to kind of pile in to see if people want to watch it. It is a 4-to-1 planetary gear system being pushed. It's basically, let me start with an explanation here. Hold on. Gotta get my tobacco going. So what we're dealing with here is a 22 blade high pass fan, 170 millimeter. It is being driven by a Flip Sky 6374 190 kV 48 volt motor that's usually designed for the electronic skateboards. It is being run through a 4-to-1 step-up gear ratio planetary gear system. Hi, Jose. Glad you could join us. Yes, to give you kind of an idea of scale, this isn't your average EDF. As I explained before, for anyone new, as I explained before when it came down to this test platform right here is designed and recatted to be flipped back over behind the fan. This was just easier for testing because I do have metal gears coming in from PCBWay for the planetary gear system. What we're going to do today is we're going to run the Nylon 6 gears. This is the last set of Nylon 6 gears that I have. They will last a little bit longer than the PETG did and the PLA, but eventually it's going to roast that sun gear in the middle because you're talking about a lot of torque going in there. So, hey bro, can you? Yeah, you want me to do it now? I'm waiting. I was waiting for some people to come in because I didn't want. This is my last spin up before the planetary gears get here that I had 3D printed in aluminum, and they're in flight right now, so they should be here stateside pretty quick. And I'm still looking for a stateside solution so that I can get a lot of this printed in aluminum. The hub for the fan was redesigned, and as you can see, the hub is designed to basically where you can take off each individual one of these, and this makes it easier to CNC this unit. So I'm either going to 3D print it, which is I think what I'm going to try and do first. I'm going to do the hub in tool steel, and I'm going to do the blades in 7075, or the 3D printing equivalent, which is, I believe, is the aluminum IGS or something like that. So the idea is, how fast can the fan go? Well, the projected speed of the fan based on the motor and the step-up gear ratio is 32 to 35,000 RPMs. And we're going to get things powered up here. And on this test, you're going to see what happens when it hits a specific power band when you're using 3D printed gears. Now, I've heard of PEEK. This is PEEK. That's a type of filament that people are saying is extremely rigid. It's extremely strong and will give me, it's comparable to aluminum. But I don't know about that. And I don't know if the Bamboo Lab X1 Carbon can actually print PEEK or any kind of PEEK CF or PEEK with glass infill. There's a lot of other materials I could use in FDM in order to make these gears. But if you look at the size of the teeth on these things, it's got to be really good material or it's got to be alloy. And that's just the long and the short of it right there. So, let me get things ready. See what we got on amps here. Everything's good here. Okay. We are chained up. I do have chains behind this because the rope that goes to the scale and the chains together will ensure that it doesn't, well, take off. So what I would like to do first, thank you for that, Todd. I'm glad you're here. I'm glad you're here to see this. And yeah, I had to really figure out a way to not just 3D print or CNC the whole blade as one piece, but to actually make it where I could CNC it or 3D print it out of different alloys to make sure that I had the strength I needed. But the first goal of this whole endeavor, and that's why I'm still waiting for those aluminum gears, is to make sure that this planetary gear system here that I've designed and put in here is going to hold out. And we know with PLA and all that other stuff, it will spin. So what I have put some lubricant in there. I'm kind of let it just roll for a little bit and see what I hear at a low RPM, and then we're going to send it till it kills that sun gear, because that's the first thing that's going to go. All right, 1 second. Sounds like a diesel engine. Okay. Now, the idea behind running this in is kind of letting everything mesh together. Okay, so when I send this, it's basically going to go pretty quick. You'll see it. You'll see the whole engine move forward on the caddy, and then it's going to eat the sun gear and destroy itself. But does anybody have any questions about what I'm doing right now and what this engine is for before I get started? Josh, welcome to the chat. Glad you're here. So I knew it was going to be kind of a slow chat or a slow live today, just because of the time of the day I'm doing it. But I had the nylon 6 gears and I wanted to go for it. Let's go ahead and get ourselves ready here to spin this thing up. Now, what's going to happen is I'm going to get close to half throttle if I'm lucky. And then you're going to hear that middle gear strip out. You're going to hear it. It'll whine. And then that'll be the end of it as far as that goes. And then you can ask questions about it. We'll take a closer look at it, so on and so forth. But when the aluminum ones get here, we're going to be able to hit the highest power band. No, not metal gears yet. These are nylon 6, Daryl. These are nylon 6 I printed up last night because I knew they would last a little bit longer. But they're not. I appreciate it, Josh. Thank you very much. Welcome to the club. There's a lot more to go. Not just the turbofan, but to finish answering Daryl's question. Let's break them. You want me to go ahead and break them? We can go ahead and break them. I mean, it's not like I didn't think they were going to last anyway. So let's go ahead and break them. Give me a second. Have to herbally prepare. Todd, welcome. Welcome. Well, to kind of explain to you what is going on, give me 1 second here. Your message was retracted. I didn't get to see it, Todd. This is a 170 millimeter high pass EDF being driven by a flip sky motor for a skateboard. The reason why I needed the torque was I needed a 190 kV motor that ran on 48 volts to spin the 4-to-1 planetary gear system that's in there. You've been thinking about this one? Well, it could be a short run, and it's probably going to be. So don't be surprised. We did do a little bit of running up, added a little bit of lubrication. So at idle speed, you can kind of see it's fairly stable, but it is making a little noise. So I'm expecting failure, obviously. But when the metal gears do arrive, I won't have failure because the ring gear and all the planetaries and the sun gear are all done out of the same alloy. So it's going to give us a lot more of the power band. So that's what we're doing. And Josh, to let you know what's going on, this is basically an engine you can put in any RC aircraft. Fairly big one, but the ductwork that's around that right now is just the ducting for the test work that I'm doing right here. All the testing. The final design will carry the drive system from the front to the rear, behind the fan, inside the ducting, and then the entire system can be dropped into whatever plane you want to. You can get a large scale F-22, you can get a F-35, whatever you want to build. And I am going to be building a drone with 4 of those engines, 4 of them, for a total output thrust of 220 pounds. So, how many we got? We all ready to see this thing go? Who's ready to see this thing go right now? Let's get the hearts up there. Come on, reactions. All right. I was hoping some more people would roll in, but you know how it is with these lives. So, for those who are here, let's see what she does and when she fails. Now, this is probably only going to last a few seconds, like I had told you before, so don't be disappointed. When I get the aluminum, it's going to last a lot longer, hopefully permanently. All right. Almost got to about half throttle on that one. You can see it wants to still grab, but it's stripped out. And this is typically the issue I've had with the 3D printed gears. So I tried like every material I could. And basically they all failed, even Nylon 6. Which is why I was looking into Peak. So, yeah, the sun gear is gone. The sun gear is... The middle, what it is the middle gear ends up looking like this. The sun gear that drives the fan ends up looking like this afterwards. And that's why I had them all done in aluminum. Starting with aluminum, moving to stainless, probably tool steel is going to be my end all be all for this thing as a final fan. But even with stripped gears, it'll still spin it at low RPM. So that's what I've been dealing with for the longest time, and I knew that I was going to have to order the gears. Unfortunately for me, there aren't a lot of places stateside, at least that I have found. Everyone's like, PCB ways, go with them. So I went with them, and I ordered those gears on the 1st of February. They're on a plane, from what I'm told, 4th day in transit, on a plane. And this was after watching them make, do all the printing, all the programming, and then doing the post processing, and then doing the quality control check and getting it packaged and then getting it out to me. Now, that's taken a very long time. So I'm kind of hoping one of these days I can find a stateside solution for this system. So that I can have what I need done in metal, or I can have something CNC'd, and the people know what they're looking at, because they're looking at my files here and they're going, oh, well, we can't do that. We can't CNC that. We can't do that. I mean, it can be 3D printed easy enough, but I don't know. I was trying to go for CNC because of the tolerances that I put in the model. The PETG fan here, it's all one piece. Now, ultimately, I'd love to have this fan. Here's another version of it, because when it's driven from the rear, it's basically going to be, it's going to have the Madonna tip on the front here. But it'll be driven from the rear and with this system. And I would love to have this whole thing just CNC'd in one piece. Would love it. But I don't know anyone that could do it, to be honest with you. So I've gone back to having to re-engineer everything to something that could be 3D printed in a metal 3D printer or CNC'd piece by piece. I can have this 3D printed from PCBWays, but for the hub and all 22 blades, they want like $340. I already spent $114 on just the planetary gears and the ring gear. So if I were to have this entire thing, everything I wanted printed in metal or CNC'd, I could probably buy the machine that they did it with. Because I went to another place, Proto Labs, and I uploaded the fan, and they're like, oh yeah, we can do that for about $2,200. And I'm like, what? Are you kidding me? So I need to find a good stateside solution, something that isn't too expensive. Yeah, the bottleneck at the moment is basically the planetary gears. Once they get here, we'll be able to prove them pretty easy, because we're going to do the same thing we're doing here, except we are going to be doing it with the aluminum. And as you could see, once it started to pick up speed, because I had it on a soft start so that I didn't have any high torque at the very beginning. And once it got to a certain power band, it just cooked that sun gear just like that. So that's been the issue really the whole time. Now everyone's like, you can go get bigger gears. I'm like, well, yeah, I could make them bigger, but you know, and they're saying put thicker teeth and less teeth. The idea behind a 4-to-1 system is that you have to have a specific number of teeth on the ring gear, the planetary gears, and the sun gear. That's all there is to it. The sun gear and the planetaries have the same amount of teeth on them, and then you have the exterior, which is closer to like 75 or 78 teeth, something like that. I can't remember. So it has to be, it's all about the teeth, the number of teeth on the gears, not the size of the gears, but the number of teeth. The sun gear, which is the output, can be dropped in size to say go 2-to-1 or something to that effect. But right now we're set at 4-to-1. And since it's stackable, I can take another carrier system, it'll fit in this box, and I can put it on there and make it 16-to-1. But something tells me that the 4-to-1 and 35,000 RPMs is probably going to be enough. Especially with the PETG fan, considering the PLA fan that I had on the first WV1 exploded really close to me. So I'm trying to avoid that this time. So yes, the bottleneck at the moment is really, for me, it's about wait time. And I want to bring you guys content as often as possible. But it's really about the wait time when it comes to me having to outsource any kind of alloy printing systems or anything alloy that needs to be printed. So that's what slows me down. That and waiting for parts. It's always waiting. So I've got to wait for an ESC for the plane that I have over here. I'm waiting for wire extensions so I can finish its construction. That's a 90 millimeter EDF plane. That one I designed in Fusion, and it is basically, it's a unique style. Everyone's looking at it going, you know what? That's not going to fly. Even if it floats, I'm making progress. Yeah, that's my fun one right there. That's completely experimental from the get. Well, what questions, Todd, are you? I mean, ask. I mean, there's plenty of videos. I have a lot of different playlists. This originally started with the Shrike drone that I put together, and that playlist is out. You can kind of see where I started on that. And I had originally had a triangular design, a tricopter design with a pusher motor underneath. And that was this one here. And I was trying to do this analog. So this whole thing was just, what it was 64 millimeter motors is what I had in there, and I was running the ESCs here, battery packs for each individual ones. And I wasn't even running a flight controller. It was a straight RX from a transmitter, you know, regular 2.4 gigahertz. And then I had a pusher motor section here, and servos rotated everything for the pitch and roll axis on the tricopter part. So that was what I started with originally. And then I realized I needed to get more familiar with how EDFs interact with flight controllers. So I built the Shrike, which ended up being version 10. And it was that FDE colored one that's in the playlist. That one went well. The first one was white, and I used analog ESCs. Still using a SpeedyBee F405 wing, but what it ended up happening was I just didn't get the response time I was looking for. So I went to D-Shot ESCs, and that they're from iFlight 80 amp D-Shot, I think the EVP V3 or something like that. And then we had the issue with power distribution. The video with power the problem I had with power distribution was with 470 millimeter EDFs, I was pushing a lot of amps, so I had to find a board that would work for that. So what I did is I ended up finding a APD power distribution board, which gave me, it was a 500X. And I'll pull this. This is like pulling out the nervous system of something here. This is the gaggle I have to take apart again. This was originally on the original Shrike drone. And you see you have the iFlight. I gotta fix that. This is the ADP power distribution board. All of my soft serve welding or soldering. And this actually worked. If you see the drone in the video, you'll see that it worked very well. But I gotta scavenge all that stuff back out so I can put it on the next drone, because I want to do another Shrike drone and just have one, you know, I can play around with. So if you go and check out that playlist, Shrike drone, I also have a Javelin, which was kind of the same concept, but it was more of a tail sitter design using the Shrike's concept for lift, so VTOL, and then rotate into forward flight mode. I didn't finish that one yet because I had issues with wiring and room and things like that, and I had to redesign a few things, but the Javelin will fly either really, really well or straight into the ground. But either way, something's gonna fly. As you can see, I put up a short earlier today where I flew the P-51. I can't stand these little planes, these little 800 millimeters or whatever. I can't do it. I'm used to big planes. But that being said, knowing that this was going to be kind of a short run, I'll give you a closer look of everything here. So this is the planetary gearbox. This is obviously the motor, the drive system. I've made it in 2 different pieces so that I can slide everything together and keyway it in. So that's attached to the fan at a 4-to-1, and at the rear in the moment there's nothing there. So, and that's because this will eventually be over here. It's already been, the CAD design for that's already been done. We're just waiting for those metal gears, and then we're going to do the same thing we did today with the metal gears. That's going to be awesome. But we did get a lot farther this time than we did last night when I did this, because I did this with like 2 or 3 sets of just PETG gears, PLA gears, and I ended up burning them up pretty quick. This one actually got a little bit farther, and it's because of that Nylon 6. Lots of projects. That's next. Large scale. And then, of course, we have the 90 millimeter with the skid, the TPU tires, the Predator-looking canopy. Yeah. And then the top duct and bottom duct. And the reason why is because it's a water lander. And it can go from, it can go from the ground through the mud, through the water, take off from the water. That's what these buoyancy points are for. right here. And everything inside is going to be sealed and filled. It also has intakes here so that those bottom blades can tread the water and I can take off from it. It's DC, so it's going to work anyway underwater. I'm not using the avian that's sitting up here. It's just for testing because the avians blow up on me all the time. There will be a fin here, like I explained last night in the last live I did. That'll give us some yaw authority in the water and out of the water, and be almost like a vector thrust, at least in the yaw aspect of the craft. So the wings glow in the dark. That's always fun. I'm also adding these, which make it look really cool at night because they glow. They're those motorcycle helmet accents. And then those will eventually be glued down. So the tape's just kind of just holding them there for me to get everything in position, you know, once I've got everything done. But yeah, it's taking time to get this one together. But yeah, if you like this content, just go to any one of the places. I've got Old School RC where you can see some of the stuff that I used to fly. I did sugar rockets. I did all kinds of cool stuff like that. But that was years ago. And then I kind of got away from it because I was kind of getting into drones because my first drone was like the Blade 350QX. And I even have a video on that where it flew away from me. And I'd attached my phone to it. So the only reason why I found it is because I used Google Maps. Tracked my phone back to where the drone went down after it lost signal from the remote. So that was a fun day. But I ended up finding it in an apartment complex sitting in a bush. Nobody touched it. It's sitting here beeping. Nobody touched it. Guess in this day and age, you hear something beeping in a parking lot, you don't go near it. But yes. So what I'll end up doing, like I said last night, I will give a short or an update when I know those gears are going to be here. And I will make sure that everybody is knows ahead of time before I do another live where I'm spinning that up with the aluminum, because that's going to be done live. We'll unbox the aluminum in a short. That'll kind of give you an idea, and then I'll try and schedule something. But if you subscribe, you click the bell, you'll be notified as soon as I'm going to do something. Don't miss it, because I don't want you guys to miss it, because the outcome is going to be either a really good running fan, or you're going to witness those PETG blades get thrown everywhere. So we'll see. We got up to about, I'm going to say at half throttle, we probably got up to about 10 to 12,000 RPMs on that last run just now. So, yeah, go check them all out. I would appreciate it. I mean, every view counts. And, you know, if I'm bringing, like, joy to people's lives, that's exactly what this is for. I love the hobby. And I love to create, so kind of making new things is, and the RC hobby has kind of been something I've been really into for a little while. I also have a Patreon, and I have a Buy Me a Coffee. That's not mandatory, obviously. If you like the Shrike drone, I do have the STL set for it on, I believe, the Buy Me a Coffee website in the shop. And that's just the STLs and then a components list of what you need to drive everything. So, and then assembly's pretty easy. You'll see how I assembled it in the actual playlist. So, yeah, it went from what, you know, the triangular version to the analog controlled version to the flight controlled version using ELRS, and that was all new to me. So I had to get into ELRS and figure all that out. And, you know, programming the receiver with the passphrase and also, and I don't even have goggles. So I wish I had goggles and a camera with a VTX and I could actually watch from the sky when I'm flying these things. I think that would be a lot easier for me at this point. And that would make for some good footage, I think. You know, get a GoPro on it, and you know, like you usually do, but you're running a drone with those 4 of those. So if you take the weight of the craft that I've designed for it, the batteries, the control system, the power distribution system I'm using, you're looking at a lift capacity, a payload capacity of about 180 pounds. So it is a heavy lift drone, and it is EDF. And I know a lot of people they like to ask. They go, well, what's the deal with EDF? How is that more efficient than blades? Well, I'm gonna build a quad, and I mean a quad that you ride. Okay, it's gonna be that size. It's gonna have engines that are 2.5 to 3 times the size of the ones you're looking at, and it's going to be run with obviously a bigger motor. So this is sort of the scaled test version of all that. But I'm building a quad with it. With the flight controller and the gyro, stabilization should be really easy. It's kind of like driving a self-driving car or like driving a Tesla. You know, you put enough sensors on it, it'll be able to stabilize itself. Just like any drone, when you put like angle mode on, there's margins for safety, so you can choose the degrees in which you want that angle mode to be able to move. So that'll give you a certain type of acceleration, so on and so forth. Plus, there's variability in you moving around on the quad. So, I mean, once we get to that point, then most of my shop will be full of just TIG welders and jigs getting the frame set up, because I'm going to have to make it as light as possible. And then I'm going to fly it. I'm going to be flying around on this thing. So I know it sounds crazy. My wife doesn't want me to do it. She's like, do it remotely. I'm like, well, we'll have to get a test pilot. We already have one, PXD. He'll be on there to do it. Yeah, basically the same thing. Yeah, that's exactly right. Cami Complex. It'll be the same exact thing. It'll try to auto correct, but what really kind of sets that apart is you'll be able to lean into it, and it'll auto correct, but it still has to pull out of that auto correct, and you making the turn will be, you'll be able to make the turn, and then the gyro will auto correct. We'll make it a soft auto correct, and then obviously a bank limit so you don't end up flipping over. That's realistically what we're looking at. But this engine so far, 55 pounds of thrust is what I got. 0.665 kilograms kilograms per second air volume. So it's moving some air. It's moving a lot of air. The only thing that I had a concern about was possibly, drones they like to make really fast corrections in their motor speed in order to maintain stability. Now it can still do that with EDFs because they spin a lot faster. So you have to change the response time. You have to adjust the gyro frequencies, everything else, to make sure that it flies right. So once I get this thing hovering in the drone mode, what I'm going to end up doing is after it's dialed in, I'll be saving all those settings and then applying them to the larger system so that I can control it better. Because we're not just dealing with a direct drive like in most scenarios with drones. You're dealing with an engine that's getting pushed through a planetary gear system, which is going from 1 rotation to 4. And then it should still act the same as long as the power band and the RPM range are locked in. Then the flight controller should be okay with it. It is going to react slower. It's going to react a little bit more sluggish, obviously, because it's probably 10 times the size of a standard drone in its class. And it's, well, I mean, this isn't a class of its own. I'm going to be just straight up with you. If you see, I mean, 4 of these things running on 2 6,000 milliamp packs. So you're looking at 12,000 milliamps per setup at each corner of a quad style drone. And then that's going to be pushed through 2 Tero 480 amp power distribution boards. And that's all going to run up to the SpeedyBee F405 wing or a Mytek. I haven't tried the Mytek yet, mainly because I just haven't. I had SpeedyBees laying around, so I use those. And I don't know if there's a better flight controller out there that I should be using. Again, because I'm, you know, I wasn't really into FPV, although I'd like to be. I'm more on the creation side. So yeah, this is going to be a big drone. It's going to be a big project. It's going to be a big drone. It is going to be 3D printed. The spars that hold this to the body are carbon fiber spars, 20 millimeters or 22 millimeters in diameter, and there's 4 of them. So it's going to be pretty rigid. We should get some interesting... Hey, Daryl, thanks for stopping by. And I will see you again soon. And don't worry, you'll be notified as soon as those metal gears get here. Anyway, other than that, the idea is to get this motor working properly the way I want to, then reprint the drive section, which has been redesigned to run at the rear. That will put the CG of the motor right in the middle. I know that doesn't really matter too much with drone. Well, it kind of does, because if I have a lot of my weight up at the top, then it could lean too far into a bank and try to overcorrect. So putting the engine drive assembly right behind the fan kind of keeps not only the whole powertrain and the thrust aperture close to the CG, it helps with stability in drone mode. So that's really the whole goal. So until we actually get those metal gears, I'll be doing some shorts on other stuff, maybe some videos. I did try to fly the plane. That didn't work too well. And I'm talking about this one. This is my nemesis right here. I'm gonna have to print another prop. This thing's driving me crazy. I'm used to bigger planes. So if you like the older style planes where you're, you know, the bigger planes, bigger gliders, you can check out, I think I have an old school RC playlist where I was flying back in the day, you know, and that pretty much was what I did. I flew gliders, I flew gas powered nitro planes, things like that. And it was really a lot of fun. And then I kind of got into the drone side of things and EDF side of things. And I had a lot of criticism with the Shrike of people telling me that's impractical. It's not going to work. What's the point? And I said, it's a concept. It's a concept drone. So it doesn't necessarily have to outperform agricultural drones per se, as far as flight time and things like that. It's about being a conceptual design and then seeing how it operates, and then finding a more efficient power system or a way to distribute power evenly, or to use draw less amps, or so on and so forth. So if I were to spin this up with a standard RC engine, you know, like a 650 or a 500 kV, it would smoke the motor. The motor would smoke. It would just, I'd burn it up. So I had to go with more of an industrial kind of motor. And this one, again, is for skateboards. It's for those electronic skateboards. Never had one. I'd probably get, you know, break my leg on one. But they are the right kilovolts and the right kV and the right voltage for this application. Because I'm looking for the torque generated by this to not, so it doesn't overheat, in a sense. And this is how I keep it. You know, if I'm up to about 115 amps in short bursts, it's fine. 80 amps is ideal. And that should give us an overall RPM of 32,000 at a minimum. So that's what we're working on. And with that, again, I knew it would be a short live. We will get back into this as soon as the metal gears get here, and we will spin it up again. But I have to admit, those nylon gears held out a little bit longer, and it sounded really, really good. Now, when you see the other one, I'm going to try and get the audio through my Rodecaster Pro, and I have an NT1 mic, so that should give me some good sound. I'm going to try and get that sound in so you can really hear this thing wind up when it gets past that power band where I keep failing with the printed gears. Because it sounds really good. Because a lot of my direct drive versions of this motor sounded awesome. I mean, absolutely awesome. If you want to see something real funny, the one fan that did explode, it's sitting back there in that corner. That's the internals of it right there. And I did a video on that, said that where I named it for all the EDF lovers out there. And it was a slow-mo video of me just getting blasted by the thrust coming out of this thing. And it was just hilarious. So go check that out. And don't forget to join the Discord if you haven't already. And I have Patreon, and you don't have to buy me a coffee on the site. Buy me a coffee, but hey, I love coffee, right? And realistically, anything I get helps me to get more hardware for this hobby. Everything I get for this, I put into it. Because I personally, you know, I'm on vet benefits, so I don't have the income to just kind of dump all my money into this. My brother has helped, you know, he's helped me with the printer. He's helped me with parts, stuff that I need to order, things like that, to basically keep things going, because I have an end goal in this. So until we get to that point, you know, it's I hate waiting. I'm sorry about the time that it takes for me to get longer run videos or lives out where I'm spinning this thing up. But it's really just because of the manufacturing process of the 3D printed gears that are done in metal, how long it takes to get here, where they're coming from. That's another bottleneck that I always have to deal with. But if any machine shops out there want to take this on, I've got the files. So well, let's cut some metal, you know, get this thing where it needs to be, get that power that we're looking for. So, all right. Well, you guys check out the other playlist. Tell me what you think of the Strike Drone, and if it's something you'd like, you know, something fun to fly. You know, it was powered by a 6,000 milliamp 22.2 volt. And it ran for a considerable amount of time. Not like 10 minutes, but at least 5. And, you know, during testing. And a lot of people told me I wouldn't be able to fly that long. I guess those people didn't realize how big the battery was. But it could carry a 4-pound payload by itself. And that's what I liked about that drone. And running EDFs. So, again, thanks to those who stopped by. I hope you enjoyed it. I hope you got a chance to see it spin up. If not, scroll back until you see me spin it up. It was cool. And then stick around for the announcements for the next time when we start spinning this thing up with aluminum gears. Till then, thank you for all for stopping by, and I will see you again next time.